section dinner and technical discussion. We have Atieh Ghadiri presenting for us today. She's a product specialist with the technology department of HF Sinclair Petro Canada Lubricants. She's got more than 15 years of experience in the industrial lubricant sector, specializing in research and development, product design, product qualification, and validation processes. She's been involved in developing high-performance lubricant solutions for a variety of industries such as manufacturing, energy, mining, forestry, and marine. She is an STLE member and OMA 1, and is primarily focused on high-performance and specialty hydraulic fluids at the moment. So, thank you.
Thank you very much. Hello, everyone. Good evening. Thanks for attending this session today. This presentation is supposed to offer a glance into the EAL world, environmentally acceptable lubricants. The topics of discussion are primarily what is an EAL, some criteria for the assessment and evaluation of the EALs, plus an introduction to major regulatory programs and eco-labels, and then just a little touch on fluid design, base stock options, additive options that are available for designing the EALs. So what is an EAL? I will not keep saying environmentally acceptable lubricants. It's a mouthful, so we'll stick to EALs. Environmentally acceptable, environmentally friendly, considerate, benign, biolube. These terms have been used for a few decades, almost interchangeably in the industry. They have been used for lubricants that were imagined to have a less negative impact on the environment compared to conventional, mostly mineral-based lubes. But how can we define an EAL? Because sometimes it's about biodegradability. Sometimes it's about being less toxic. Sometimes it's having a bio-based portion or some renewability claims. Sometimes it's about sustainability, some sort of lower carbon footprint. So what is it really? Is it all of those areas? Is it just one? Because sometimes you look at some market research, for example, from Klein, and they say if you meet one of these criteria, you can claim being a biolube. But that's not really accurate. So yes, there is consensus that EALs, which is the more and more common term for more environmentally friendly and acceptable lubricants, there is consensus that these are lubes and greases with improved environmental impact. And they have minimized adverse effects on the environment compared to, again, conventional mineral-based lubes. But there are three pillars that basically most of the regulatory programs are relying on to define EALs. For example, the US EPA defines the EALs as lubricants that are biodegradable, minimally toxic, and non-bioaccumulative. More or less, other regulatory programs and eco-labels are in agreement with this definition. And there is also a lot of effort, increasingly growing effort to define, standardize, regulate EALs on every front: formulations, technical requirements, environmental properties, areas of application, and so on. So I would like to focus first on those three major properties: biodegradability, When it comes to the EALs and we talk about biodegradability, we are talking about ultimate biodegradation. It means that a compound should be totally utilized by microorganisms, and it should be converted to carbon dioxide, water, mineral salts, and also more biomass. So pretty benign, harmless end products. So that's ultimate biodegradation. There are other types of biodegradation that you may hear elsewhere, like primary biodegradation, which is basically referring to any change to the compound as is in the beginning. And that's not really what the EALs. Okay. Sorry for that. Where were we? Ultimate biodegradation. So that's what we mean, and most of the regulatory programs mean by biodegradation. OECD 301 is, I can say, the most popular guideline for testing biodegradability. It has 6 methods within the guideline that can be used for assessment of biodegradability of different compounds. They can measure dissolved organic carbon, the amount of CO2 that is produced, the consumption of oxygen. So there are different methods within the OECD 301 that can be used for different types of chemicals. OECD 301B is almost the most common one that we use, or everybody uses for lubricants, because and which is followed by 301F. These are the 2 most common methods for compounds with low water solubility, lubes. The way the test is set up, it measures whether it's the consumption of O2 or the production of the CO2. It measures the percent degradation within a period of 28 days. And in the OECD 301 itself, 301B and F, there is a limit of 60% where you can claim, if you pass that, you can claim that the compound is rapidly or readily biodegradable. If it ends up being between 20 to 60% within 28 days, it means that, yes, it degrades, but not fast enough. It's inherently biodegradable. A typical biodegradability chart would look like this. The blue line is the test substance. There is always a positive control to make sure that the inoculum or the microorganisms that are in the test are active enough. So they are actually degrading the positive control. And then we can see that, for example, this compound at 60%, it has passed, or it has passed the 28 days. So it's kind of inherently biodegradable. It did not reach that readily biodegradable limit. In the OECD itself, there is a 10-day window requirement too, which means that when the degradation passes 10%, you have another 10 days to get past that 60%. But this is within OECD. So when we talk about regulatory programs and biodegradability, normally we don't say readily biodegradable, we just say biodegradable, and there is a consensus to disregard this 10-day window because of the complex material that we are dealing with when testing lubes, and they go through consequential degradation. So the end result, the 60%, is more important for assessing biodegradability. Toxicity is the next important property. Toxicity could cover a lot of things. It could cover health hazards, including CMARs, carcinogens, mutagens, reprotoxins. It could deal with organ toxicity, sensitizers, or compounds that could cause irritation to skin, eye, or have some sort of respiratory irritating properties. Pretty much these substances are excluded when designing EAL. So the products or even the components should not be at the treat rate limits, should not have any hazard classifications for the finished fluid. What most of the regulatory programs and eco-labels are concerned with is aquatic toxicity. Also, looking at the biodegradability, a lot of the tests that are designed for the EALs deal with the marine environment. They are done in aqueous environment because that's one of the most important areas of application for EALs in general. So these aquatic toxicity tests could be done in two different ways. They could measure the acute toxicity, or they could measure the chronic toxicity. Most of the eco-labels prefer to have the acute toxicity data. Chronic is allowed and considered under certain conditions. But there are three tests for the aquatic toxicity: the acute toxicity, which will measure the toxicity for algae, daphnia, and fish. Some other separate test methods exist for bacteria, soil, but they are not really the topic of our discussion today and not generally considered for most of the eco-labels or regulatory programs. Bioaccumulation. So bioaccumulation potential pretty much applies to the non-biodegradable portion of the products, because the assumption is that the biodegradable, whether it's readily or inherently, it will biodegrade and disappear at some point. But if it's non-biodegradable, then it should be not bioaccumulative, and it should not cause any, in the long run, biomagnification up in the food chain. There are certain test methods for measuring bioaccumulation of the chemicals. Pretty much most of them are based on how big the molecules are that can pass through the membranes easily enough or not. Or like the partition coefficient is measuring how much the affinity of the compound to remain in the water or in octanol, that is a fatty, representative of the fatty tissues. So that's pretty much bioaccumulation, but we deal with it only for the non-biodegradable portion of the components. There are many eco-labels around the world. Some are national, some are international. I personally think national doesn't mean much, really, because of today's trade and economy. Like, everything is passing all the borders possible. So pretty much in that environment, those are could be considered all international programs. EPA has the Vessel General Permit Program. Swedish Standard has certain eco-labels for grease and specifically hydraulic fluids. Eco-label, European eco-label is pretty well known. And for example, on top of that, Germany has its own Blue Angel eco-label. I am going to focus on Vessel General Permit, Swedish Standard, and eco-label just to go through some differences, requirements, similarities between the three. And in general, the regulatory programs, in addition to biodegradability, toxicity, and bioaccumulation that we talked about, could have other components to them. They could have requirements or optional requirements for renewability or bio-based content. They could have further restrictions on chemicals and substances that could be used in the fluid formulation. They could have or have some technical or performance requirements, some minimum performance requirements for the fluids. And they also could have some packaging, labeling, disposal requirements as well. These are pretty much found in the EU Ecolabel program. Some are self-claimed, some do have application assessment and verification processes, and actually when you go through those processes, you can use the Ecolabel on your product label as a certified EAL. So starting with the EU Ecolabel program, this Ecolabel starts by dividing the fluids into three classes based on the type of application, whether it is accidental, partial, or total loss. It's an extensive program, so when I say lubricants, we will get to it in a couple of slides, but it could cover greases, hydraulic fluids, metalworking fluids, gear oils, a lot of different types of lubes. So it places these, you can see it in the table, based on that type of application, classifies all these into whether it's into these three groups, whether it's an accidental loss lube or it's a total loss lubricant that is going to be discharged into the environment per the normal operation of that equipment. Once that is decided, there are certain different environmental properties required for each class. So of course, if it's a total loss lube, it has more strict, stringent requirements compared to something that could be accidentally released. And there is also technical requirements for each type of lubricant here. As an example, we can look at the toxicity requirements, the aquatic toxicity requirements. So anything that can be considered non-toxic does not have a limitation for use. As a formulator, you can put as much as you like. But then if it's harmful, depending on which category that lube belongs to, there is a certain limit that you shouldn't exceed. In terms of evaluation, any component that is intentionally put in the lubricant in excess and in excess of 0.1% needs to be assessed and has a clear classification here. Maybe looking at biodegradability makes it a little easier to compare. So we see that the readily biodegradable portion required for an accidental loss is 90%, is a minimum 90%. However, when we move to total loss, it's 95%. It's the same thing for as you move down to non-biodegradable, non-bioaccumulative, the treat rate limitations increase. And then, of course, you can pretty much just put 0.1% for the bioaccumulative portion of your components. Here's an example of what that requirement for technical performance looks like. So there is either an ISO standard that will define the minimum technical requirements for that type of fluid, or if that doesn't exist, the fluid needs to be fit for purpose. For most of them, it means that you have to have at least one client that has used and approved this fluid and can attest to suitability of that fluid for that application. Moving to US EPA's VGP. So VGP stands for Vessel General Permit for discharges incidental to the normal operation of vessels. So it is applicable to all non-fishing vessels, large non-fishing vessels greater than 79 feet in length that navigate in US waters everywhere. The VGP is not only about lubes, it's also, or not any certain type of lubricant. It has, it's covering different types of lubes, greases, plus all other sorts of detergents or ballast water. So it's very extensive. The lube portion of it requires all vessels to use an EAL in all oil-to-sea interfaces unless it's technically infeasible. It does have requirements for environmental properties. However, it does not really require any minimum technical requirements or performance requirements. It's still in effect, but the VGP is supposed to be replaced by VIDA, National Standards of Performance. So VIDA is Vessel Incidental Discharge Act. This was introduced in 2018, which was the same year that VGP was supposed to be reviewed again and updated. It took a little bit of time for them to come up with these, with the final rule on this national standards of performance under VIDA. Almost a year ago, I think in September 2024, this final rule was released. But the reason that VGPs is still in effect in the interim is that the U.S. Coast Guard is now responsible for developing regulations for implementation and of these national standards, and that is probably going to take a couple more years. Major changes that will be in effect when VIDA replaces VGP is that there's not much changed for biodegradability requirements, aquatic toxicity, or bioaccumulation. However, there are a couple of interesting changes. One is that they have specifically added hydraulic fluids after the term lubricant, as probably a good example of what an EAL should look like. The other change is that they have updated the definition of oil-to-sea interfaces to be more expansive, because before it was mostly below deck equipment or the ones that were immersed that was subject to this rule. But now it requires above deck equipment that could extend overboard or be attached to the vessel body, exterior body, those are also required to use an EAL. So anything that could cause a spill or release into the environment is now considered an oil to sea interface. There is also no mention of other regulatory programs in the new regulation, because before in the VGP, it used to say that if your product is approved by any other international regulatory body, such as Swedish Standard or Blue Angel or label, then you're automatically considered compliant with them. But that is not the case anymore, and for good reason, because VITA does not have any control over changes in the other regulatory programs. And that shouldn't be a blanket approval for the EAL. So that has been also removed. But in terms of environmental properties, there is really not much change. They considered adding the 10-day window that I just talked about in the biodegradability section, but then in agreement with the EU eco-label, they thought that this will severely limit the number of lubricants that could meet any type of biodegradability requirement for these eco-labels. So they just did the same thing and left it out for now. Swedish standard. So Swedish standard is a little different. With the BGP and eco-label, I mentioned that those are very extensive. They are regulating any type of lubricant or grease that is out there. For Swedish standard, it's not the same. Swedish standard has two major standards. One is about hydraulic fluids and one is on grease. It is not a specific eco-label, so those are standards for hydraulic fluids. There's a section in that standard that also has requirements for the ones that could be considered EAL. So it's like a technical requirement. It's a general specification for standard for hydraulic fluids, for example, and there is a specific section on the ones that can claim environmentally acceptable designations. The technical requirements have very specific test methods and requirements for hydrolytic stability, as well as some low temperature fluidity requirements. So there is some test methods that are specific to Swedish standard. And then based on the level of performance in oxidation, in hydrolytic stability, and in low temperature, you can assign a certain class to your fluid. So that it has like a designation of AAV or AAM, for example. That kind of, in the name of the fluid, it differentiates the level of performance. For the environmental portion of it, however, so Swedish standard is a standard body. It puts the standard out there. It does not have any approval or certification process. However, they work very closely with the Research Institute of Sweden that has a program to independently examine your fluid properties and your documents. And then if the fluid meets the requirements to be an EAL, they keep a list of approved fluids. It's traditionally called the SP list. More and more it's being called the RISE list for hydraulic fluids. And then they pretty much update this list every month for the approved fluids. So how do these regulatory programs really compare to each other? What does this mean? So this is really a brief glance into what are the differences and similarities. I start with the VGP VIDA and EU eco-label because there are certain similarities and certain differences. It's easy to see. For biodegradability, for example, both of these pretty much require 90%, and that's mass fraction, of the components in the formulation to be biodegradable. The rest of the 10% remaining, only 5% can be non-biodegradable. The rest of the 5% can be inherently biodegradable. So the non-biodegradable portion in both is limited to 5%. And of course, as mentioned before, non-biodegradable and non-bioaccumulative. So that is a requirement. On aquatic toxicity, both give options for testing. So depending on your fluid and the data that you have available from, for example, suppliers or ADCOs, you have two options. You can test your complete formulation and the main components. The main component here means anything that is present at 5% or more. Those need to be tested and need to be in all those acute toxicity testing, algae, daphnia, and fish, to exceed the 100 milligram per liter limit to be non-toxic pretty much. So they need to be non-toxic. One thing to again emphasize here is that all these regulatory programs are mostly concerned with the components in the formulation. They prefer each component to be tested separately and to have a clear profile rather than just a complete formulation that could have synergies or could be a little more complex to test and assess. If that's not really the case, there is an option to test each and every component present and intentionally put at 0.1% and more in the formulation. So for the toxicity and biodegradability. So that's the aquatic toxicity requirement. Bioaccumulation we talked about. And then there's renewability, bio-based content. So VGP and VIDA, they do not have any requirements for that. There is no technical requirement, and they really do not have a list of restricted chemicals here. However, eco-label has all three. So eco-label in kind of a distant past had a requirement for renewability, but I think they removed that in 2019, and now it's optional. So if there is more than 25% of bio-based carbon content in the formulation, the product can have an added claim of renewability. There is, for example, technical requirements. I showed the table for different classes of lubes. Here I'm focusing on hydraulic fluids because I focus on hydraulic fluids and it's more applicable to Swedish standard when we talk about Swedish standard. Don't ask me to talk about grease. Yeah. So there is technical requirements attached to it. Now I'm going to keep eco-label as, one thing that I forgot to mention is that the style of the testing and the options for aquatic toxicity testing is almost the same. However, the limits are different. So the limits of VGP are a little more friendly, wider, but eco-label is stricter. So Swedish standard is a different story. So Swedish standard it doesn't concern itself with non-biodegradable, bioaccumulation, inherently biodegradable. It says just 95% mass fraction components should be fully biodegradable, and that's it. The rest of the 5%, I don't care. When we move to aquatic toxicity, there is even stricter limits for the aquatic toxicity. So acute toxicity. Only anything over 5% should be non-toxic, and the rest can be like less than 5%, can be somewhere in that range of 1 to 100 milligram per liter, which is a little harmful, but it's very limited. In terms of renewability, there is again an option to have some sort of bio-based carbon content, and it should be tested per the specific test methods, 16807. And in that test method itself, there is requirements for toxicity and biodegradation. There is minimum performance requirement that both in the grease, this is the hydraulic, the 155434 is the hydraulic fluid standard. There is another one for grease, so there is technical requirements for both. And then there are several restrictions on the type of chemicals that can be in the formulation. Just as a like a blanket requirement, anything that you use should not result in the finished fluid to have any sort of hazard classification or label. Carcinogens, mutagens, reprotoxins are limited to pretty much non-existent to 0.01%. And then there's a limit for generally sensitizing compounds of 1%, which is a little easier than Ecolabel. It's not like BGP that doesn't have anything, but Ecolabel has a very, very long list of restricted or excluded chemicals, both health hazards and carcinogens, mutagens. There is even a restriction on low viscosity base fluids, for example, as that could have, because of the low viscosity, could have an aspiration hazard, which does not necessarily make sense, but it's there. So Ecolabel is very strict on these excluded chemicals. So moving on to how do we make an EAL? It doesn't seem to be an easy thing to do because of all these regulations and restrictions. So this is a good place to talk about the ISO standards, because they very clearly classify the type of base stocks that are suitable for EALs. In the ISO 6743, there is an EAL category in addition to all the other hydraulic fluid categories. So this is a hydraulic fluid specification that has 4 classes of HETG, HEPG, HEES, and HEPR. Those correspond to the type of base stock, the main base stock in the formulation. One is triglycerides, which are basically vegetable oils, polyglycols, esters, and then PAOs and other related synthetic hydrocarbons. So those are the 4 classes of base stock that, before we move on, that can be used for designing an EAL. We'll talk about the advantages and disadvantages of these base stocks in a bit, but then there is another ISO standard that I just mentioned in the Ecolabel program too, which is a technical standard. It has certain performance requirements depending on which group of fluid you belong to. So it can be different, for example, for an HEPR to an HEPG, and for good reason. So these are the good things about these base stocks. We'll get to the bad things too. But so HETG, or the vegetable oils, they have certain advantages. They are not great in terms of performance, or at least not all the performance requirements, but they are naturally occurring. They can satisfy renewability claims because they are bio-based. They are very cost-effective options, and they have high VIs. But they used to be very commonly used, but I think more and more we are seeing these being replaced by higher quality, better performers that are based on HES and HEPR. The polyalkylene glycol ones, the HEPGs, PAG-based ones, are synthetic. They are more specialized because they can be used in fire-resistant applications, for example. And they have a way of handling water because most of them can hold water. Sometimes it's a good thing, sometimes not so much. But they are more specialized for designing certain types of EALs. HES is probably the one dominating the market. And it will cover a wide variety of esters, both unsaturated and saturated esters. So the good thing about HES is that you can find any viscosity class, a wide range of price options when it comes to, depending on the quality and the performance. Of course, the unsaturated ones have their own disadvantages, but they could be cheaper. And they have high VIs. They offer good lubricity and frictional properties. So, and they are easy to get. They used to be a lot more expensive, but it's getting better. Doesn't mean that they are cheap, but just not as bad as it used to be. And then probably the star would be HEPR, because HEPR, as I said, are polyolefins or related synthetic hydrocarbons. There are not many of these around. PAOs and low viscosity PAOs used to have some biodegradability. They are not aquatically toxic. However, as you go up in the viscosity range, that changes. So you cannot have the same flexibility and viscosity range with the HEPRs. You have to be a little smarter designing. But they are pretty much hydrocarbons, and everybody loves hydrocarbons because they want a mineral oil performance with EAL credentials. They have good elastomer and seal compatibility. They are really compared to the others for systems that are converting from mineral-based fluids to EALs. Conversion procedures are easy. They don't have the headaches of the rest when draining and flushing and all. And of course, they have better performance, especially in areas that all the rest suffer, such as oxidative stability and hydrolytic stability. Now we get to the bad part. So the bad part is that, yes, vegetable oils are easy to get. They have all those good things that we just mentioned, but they really are bad when it comes to low temperature. They have fluidity issues, which makes startups bad pour points, bad. It's bad for pumping. So low temperature issues are very common with these, and really poor oxidative stability. So they don't last long. They are cheap, but then they don't last long. HEPGs are just a headache because it's very limiting when you want to convert to or back from the PAGs, because they are pretty much incompatible with everything. Seals, filters, other fluids, any type, you name it, they don't like, they are not very friendly. So it's really a headache maintaining those systems, or like converting to PAGs and then converting back. So not very popular because of that. Esters have a lot of good things to offer, and they have been around for a very long time. They are getting better and better too, because new designs have better oxidative stability, but there is a limit to what you can do to their water tolerance because of the oxygen bonds. And in the presence of water, there is hydrolysis, and they degrade. That's the plus of it, is that yes, they have good biodegradability because they like water, but in certain applications, that's not, from a performance point of view, it's not a good thing. They have seal compatibility issues, and also certain esters, depending, because there is like a huge variety of esters out there. They can be very different in design, but like certain types, unsaturated ones, they could have low temperature issues depending on the design of the base fluid. And it's a shorter fluid life compared to something that is based on an HEPR or conventional mineral-based fluids that everybody loves. Coming to HEPRs, as I mentioned, there are not many around. There is limited option for choosing a base fluid, certain manufacturers, and that makes it a little more, niche. But because of that, they have some viscosity limitations, because we can just make any hydrocarbon length to still be biodegradable. Well, if somebody is looking for renewability claims, not all of them can make those claims. There is a limit to that. And then additive selection, when it comes to the EALs, is an issue, because most of the additives that are designed to meet all those toxicity requirements and be suitable for EALs and not have all of those restricted chemicals that we just talked about, they are pretty much put together to satisfy the larger market of ester-based fluids. And they do not necessarily do well when you use the same thing in an HEPR base. There could be some compatibility issues, dropout issues, long-term storage stability issues. So again, you have to get a little smarter with the design. So where do we find these additives? The easiest place to find these, it's the EU Ecolabel LUSC list. So LUSC stands for Lubricant Substance Classification List. It's a list of chemicals. It has two parts. The first part is based on the chemical, the chemistry, the chemical CAS number, and it has all the info there. It has a CAS number, it has the biodegradation class, it has the toxicity class, it gives you renewability information, and there is, if somebody wants to use a certain chemical, can use this part. The second part, which is very useful, is based on brands. So it has the base fluids, the additives, additive packages, corrosion inhibitors, extreme pressure additives, anti-wear. So they are divided into classes. And then it gives you all those environmental properties. Plus, there is a treat rate limit attached to each and every component, which gives you some guidance of, if used alone, it could be used up to that treat rate in that certain class of total loss, partial loss, or grease, for example, application. When you use several components, of course, this becomes more complicated because you have to consolidate all the data for each and every component not to exceed limits of biodegradability, aquatic toxicity, and the rest. But they do have a really good user guide manual, and then there is the submission form that they have. If you use something from the list, it does a lot of the calculation for you. But not everything could be pink. There is certain issues with the Lusk list too. One is that you really have to keep an eye on this. This is supposed to be updated every quarter, and not always. And it's a slow, like any other regulatory body. But constantly, chemicals are listed and delisted from the Lusk list. It could be because the supplier decided to take it off. It could be because the regulatory changes really made the component not suitable, or like the treat rate, because of that reclassification, dropped so much that it's not functional at that treat rate anymore for that purpose. So it's just, you really have to keep an eye on this, and it's becoming more and more popular to go to this list because, like, for example, Swedish Standard now, in every submission that you do, asks you, you are not restricted to use chemicals that are only on the list. It's just a positive list that makes life easier. But they ask you if you are using something that is already on the list. Sometimes there are additives that are not on the Lusk list, but can be. So that could be because the supplier did not really have the volumes or the business case or the need to put it on the Lusk and pay for the fees and do all the testing and the submissions and all. Sometimes there are components that have applied and received a letter, but they do not appear on the list until the next update is done. So it's always good to ask, because there is something that you have the data for and you think can be used. It's good to talk to the supplier and see if it can go on the Lusk list. Alternatively, you can have all the data and put it as self-assessment for all the regulatory programs, that it's not on the Lusk, but these are the biodegradability, toxicity, bioaccumulation, renewability data, and measured in certified labs and based on known methods. I think that's it. Was really glance into the Yale world, and I'm open to any questions that you might have.
Thank you very much.
Really, it was a great presentation. construction when they started more systems, you know?
So, as I mentioned in the national and international labeling programs, there is certain requirements for example, companies that operate near water or like they run hydroelectric dams. It's not federally enforced yet, but we keep hearing, for example, from Hydro-Quebec that sometimes they require certain EALs for their applications, or forestry sometimes, because sometimes it's regulated. For example, if you are in marine and the vessels are going back and forth to Europe, to the States, they need to use EALs because that's how it is enforced. The vessel operators need to source EALs and use them. So in a sense, that's how the regulation works. In Canada, from what I know, I feel that most of it is really segment related, and then depends on the companies that could have accidents, spills, releases, and then they are fined and they have to.
Second year, third year, we have. They always have some kind of-
Yeah, so
Bring it to the lake. Yeah.
sometimes they are not required to in the beginning, but if something happens, then the fines are higher, the records are not as great, and then the cleanup efforts that they have, because they have to still clean it up, and those are more extensive. So sometimes in some segments, they voluntarily use EALs if it's fit for their purpose, to just not be in trouble later.
I always thought the white oil, and we was in a company, he asked me us to drink it, and I drank it. I always thought it's biodegradable.
Biodegradable or
I
food
don't know
grade?
where
Two
it
different
says.
things.
So that's a very common question, actually.
Okay.
White oils are not necessarily EAL.
Yeah. So food grade different from biodegradable. You can eat it, but it's not biodegradable.
We can eat it, the bugs won't.
Okay, so we have two questions in the chat. The first one is, both of them from Ken. The first one is for the VGP limit. For the VGP, limit is 90%, either inherently and readily biodegradable, or just readily biodegradable.
So I
You want to
find that
we lost you. You stopped sharing, right?
I did not.
But
No,
you don't see it.
Again,
You must have.
Well, yeah. Keep
I
sharing
did
and then.
not. Okay.
Okay,
Okay.
it's back. Yeah,
If I go to that slide
please.
for VGP.
Okay, good.
For VGP, it's more than 90% mass fraction of the components.
Yes, but is it readily biodegradable or inherently biodegradable? It
So
could be
here's the
both.
thing. No. By biodegradable, when I mentioned that, so the OECD calls it readily biodegradable. That readily part is not adopted by the regulatory programs. The reason is that per OECD, readily means you have to meet that 10-day window in biodegradation. So when we say biodegradable, for the purpose of the regulatory programs, it's pretty much readily biodegradable. It's more than 60% of degradation within that 28-day period. So it's kind of can be used interchangeably. They just stay away from the term readily most of the time, both because of the 10-day window, and then the other reason is that readily is really the term used by the OECD.
Okay, but you see where the confusion comes, because inherently and readily are both biodegradable.
Yes,
Yeah.
but inherently means that it did not pass the 60% within that 28 days. It could biodegrade, it will take longer. For example, it might take like 48 days. If you give it time, it will not stop. Or if I go to the slide for biodegradability,
Time is a factor.
Yes. We have
Yes.
for that.
where was this?
Inherently biodegradable. Very good.
So here, so if you look at this, biodegradable or readily biodegradable means that you have to pass that 60% in
Yes,
28
yes,
days.
I know readily means that, but the slide just says biodegradable. So it's
And that-
confusing.
And that's because that's how the EPA defines it. The EPA doesn't care how the EU defines it. The EPA has its
okay.
own written definition
Yeah,
within,
okay,
within VGP itself.
sure,
Yeah.
okay.
Even Swedish standard, they don't use the term readily biodegradable.
So as we are on this slide, did you talk about 301F as well or no?
No,
Will you or no? Is it something that is a part of presentation or no?
is there a question on
Yeah, I
301?
want to know what's the F.
So F, I think is, if I'm not mistaken, I think F is based on consumption of oxygen. I can check for you.
Okay.
But it's, yeah, I think it's based on consumption of oxygen. So it's just a different, it measures different things.
Okay, good.
And
So
I think it's used often, but not always, for greases.
Yeah, and sometimes, exactly. And sometimes for lubricants too, it's just B has proven to be more reliable for lubes, because a lot of biodegradability is about bioavailability. It's not necessarily about how the microorganisms can basically chew up on the bonds. It's how you make them available, because these are these materials, lubes generally have low solubility in water. So OECD 301B has been widely used. There's a lot of data and experience with it. So it's just pretty much the method of choice.
So next question is, what is the logic for testing components and not a finished product? And is any aging done?
In the biodegradability testing?
I mean, for the testing, yeah. So technically, the first part of the question is, you test all the components, why you don't test the finished product?
So there is an option to test the finished product on the aquatic toxicity, we talked about it, main components and the finished formulation. There's also an option to test the finished product for the biodegradability, but under certain conditions. It's just if you have only one component that is more than like 90% present, then you just test like your finished product or something like that. This is because I would imagine that I have seen this, but when you test the components, there is always data on exactly what goes in. And also when you test the components, so it's more reliable. And then it basically, for something like Ecolabel, it creates a database of components that you can use not only in that one fluid, but you can use the same base for designing 3 others and use the same data. So that kind of makes sense. One other reason is that sometimes when it's the finished fluid and there's only data on the finished fluid, there are synergies or interactions that happen that could make a finished fluid have certain environmental properties and do better. But if you test the components on their own, it may not meet certain biodegradability levels, for example. So there is that too. So when you have knowledge of the components, it's more reliable than just testing a whole lot of components in there.
follow
So
up.
the
It will be
idea of
skewed.
those,
It'll be skewed.
the idea of that list of pre-qualified material by Swedish people, that if they have these ones, that's qualified, it doesn't work. Like you're saying, the whole cocktail, and they perform different, right?
The finished fluid, yes, yeah. So
The list of
Is there
those
a chance-
areas, the slide you showed all the additives, which are pre-qualified by these regulators.
yeah, but the thing about the additives is that when you look at the additives generally are less than 5% in the fluid. So it does not really apply to the additives. They just have to have the data available. So you build it in all your calculations, making sure that you are not exceeding or you are not basically cheating the system. Because, for example, as an example, I didn't mention it in the presentation, but sometimes you have a mixture of additives and you cannot possibly have the data for 100% of all the components in there. There might be a certain percentage that cannot be assessed. It's called the unassessed portion. The unassessed portion for the whole formulation, for example, in the eco label, is limited to 0.5%, and it cannot come from one component. So you cannot say that, oh, I have this
Yeah.
material that is pretty bad and I don't want to know about it, but I'm going to put it in at 0.5%. So 0.4999, but then it has to be, so there is that too, that like additives really biodegradability is
I have
not
a follow-up question. What if all the components are good, you mix it, it turns bad for the environment? You told us the story from the other side. Components bad, they react, they're good. Now, components good, they react, they're bad.
that is unlikely. Generally, if an interference is happening, is
The upside.
to the, yeah.
Okay. So the rest of the question from Ken says now is why there is not any aging done? Like all the raw materials are fresh, right?
Yes.
When things happens on the side, they have been already been used like 1,000 hours, 500 hours, so on and so forth. Components are used now. So do you see any difference?
That has something that fortunately for us, industry has not come up with yet.
Then
And that
don't
would
mention
be
it to
a
anybody.
very difficult thing to do. We know that things change in operation, in service, in use, and for now, all these regulatory programs are centered around fresh fluid properties to make sure.
But it's a comment, if you get a spill, it's not fresh fluid normally, it's used fluid.
No, that's totally valid, but it's like there are certain limitations. If you want to look at these tests, there are a million things that need to be changed. Like that OECD method is from 1992. So like fresh or used, it needs to be revisited, for example. But that would be a very difficult thing to do too, because there are a million different configurations of equipment, operating conditions, how fluids age, and probably something for the
Excuse
future
me?
after we
Okay.
retire.
Do we have a same standard for the antifreeze?
I don't think so.
Like a coolant for
Yeah,
the
like
diesel
a
engine
coolant,
coolants?
yeah.
Okay. No one
Because
has that.
because most of the time, because of the leaking, we have some problem for the ELA standard. I think it is because of the leaking. Yeah.
EALs are commonly sampled in use and analyzed by companies like Polaris and WearCheck and Lab 1. And the people who make EALs are very familiar with what condemning limits would be associated with their formulas.
So the last question that I have, which is somehow similar to Ken's question, it says, the finished product might have been contaminated during delivery. How to check EAL finished product after contamination during the delivery?
Well, I think in that sense, the EALs are not different from any other product, EAL or not. There should be checks and balances in place to make sure that the chain of custody from production to delivery is intact. And if there is something that that could have happened in that process, there's always the same. I think the same practice applies to EALs as it does to other products. You just have to work with the supplier and have a baseline for an uncontaminated fluid, and just run the testing, check the physical chemical properties, and make sure that before use it's still.
I would, that makes sense, because I mean, regardless of what it is, what the application is, you have to have quality control, to check the parameters, check everything, do a stability test, and see if it's good before you move forward. And it's just you quarantine it, and it's great. Not
Those tests are very commonly run, particularly when you're switching out from one EAL to another. If you're changing technologies, you'll run FTIRs and oil analysis, run elementals and the whole 9 yards, and then you'll determine how well your flush out is accomplished. And there's a standard in the ISO standard for flushing efficiency too that covers that kind of thing.
Great. So I think the last question is, what is the drain interval for EAL products? I mean, how to check the finished product is still good for future usage? Ahmad, do you mean like a used oil testing for EAL? External, yes. Just
Yes, Behzad. I mean, like
yes.
all the oils while usage, it get depleted. So we keep testing, and once we reach the certain level, we change it or recommend. But since we don't have any finished product test for biodegradability, so we cannot check whether it's still the product is good or not.
So that's kind of the same question that was asked earlier about the used fluid properties and environmental properties changes. We know that things change. There is no really standard regulation or requirement to test the used fluid for environmental properties at the moment. The requirements are around the fresh fluid that goes in certain areas, certain applications, sensitive environments, and that applies to the fresh fluid. So as long as that is satisfied, normally these regulatory bodies are happy. And then the what the user should be focused on is basically what Larry just mentioned, is that you do not mix and top up different types of fluids. You do not, you commit to good conversion practices based on what either ISO standards suggest or your supplier suggests, and make sure that what goes in the equipment is representative of the fresh fluid, and that can maintain the fresh fluid properties as advertised. Then in use, there is really no regulation or requirement to keep testing these. Keep in mind that these tests are not like density viscosity testing that you run in the lab. These are specialized tests that certain GLP labs run, and it's not something that is even feasible to run for like as a monitoring program. what the user should really commit to is identifying a good product, good conversion, and good chain of custody to make sure that the product is good when it goes in. And then based on the type of the product, does a monitoring program appropriate for the type of base stock that you have, for the quality, the type of the fluid, because these could be very different. Like something like an HETG class, a vegetable oil, could have an RPBOT of 15 minutes, while an ester product or an HEPR product could have an RPBOT of 1200 minutes. So then you have to have your proper monitoring program in place to monitor the performance, and to let more focus on performance like any other oil, less on the environmental properties.
As a user, if I buy this product, if I
Louder. No, louder.
so yeah, if I buy this product, probably I buy the full package from the manufacturers, buy the testing also, and probably then test COP. So I have a baseline, and as the manufacturer every so often, frequency, month, 6 months, to test it and let me know, right? Those specialized test results.
Yes.
Not only,
Yeah.
you know,
Yeah. So
I mean, in old time, for example, the polyester we used to buy from Forceline. The mandate was that they were doing all of our testing back then, and plus supplying us the oil, and then more sophisticated, they were out of business. Yeah. Things change. So things can be done in a variety of ways for users to bundle it with the contract.
yes. Yeah.
Okay, thank you very much. I think you have a question. Irina.
I want to know about the technical performance in EAL programs. Something is different. I think that in the table, mentioned about the technical performance.
Like an ISO standard?
Yes. So there is technical requirements for the eco-label products. They normally refer to a certain ISO or DIN standard that is designed for that type of EAL. For example, in this table, I showed that 15380, the ISO 15380, is only concerned with the EAL category. Because when you go to that 6743, it will break down all the different types of hydraulic fluids. There are conventional hydraulic fluids, there are monogrades, multigrades, mineral-based, there are EALs, they are fire-resistant ones, and they all then have different ISO standards that will define certain performance requirements for these type of fluids. So it's a separate standard. You go to that standard and there is different performance levels. For example, for HETG is a separate table, for HES is another one. Similar to what you have for a mineral base, that you have a monograde, you have a multigrade, you have high pressure pump requirements. So those are really performance properties.
Okay, cool. So there is no question in chat, but Ahmed, you have raised your hand. What's your question?
Just a quick one. This has, brought me to one question, is that what is the shelf life of EL products? It's like normal mineral oil or synthetic oils, or it differs? Because it feels like biodegradability has got certain aging factor.
It does not. It's really shelf life. So EALs are a class of their own, but there are still loops, and the same rules apply. For example, for shelf life, it's really it depends on your fluid design. So it should come from the fluid manufacturer and designer, depending on their knowledge of the compatibility and storage stability of the product. So it's no different from any other type of fluid. So whatever they have studied and assigned, that holds. Biodegradability, if you remember when I talked about the test, it doesn't mean that the fluid will degrade on its own and decompose it sitting on a shelf. it is a good thing when the fluid is spilled or released. For example, you have a boat that had a leak, and now, I don't know, X liters of oil are released in the lake. So that means when exposed to that marine environment, it doesn't stay, it doesn't kill the species, it doesn't, and it will degrade eventually, because in a water environment, you cannot clean it up fully. So that's the meaning of biodegradability. It's when exposed to microorganisms in water, it will degrade and decompose and will form non-harmful byproducts. It doesn't mean that the fluid itself is unstable.
Good. Thank you very much.
Thank you.
Thank you, Ahmed. You purchased the boat. We go for fishing. Okay.
Together.
Bring the oil. Okay.
Yeah, sure. Thanks a lot. Thanks a lot.
Bring the oil. You bring the boat. Okay. Good. Okay.
Thank you very much.
No worries. I see no question in the chat. There is no question in the room. So
I think we can wrap this up. So thank you very much, Atieh. Appreciate your time. Thanks for coming out. And everyone else, we look forward to talking with you in maybe 4 weeks, if not before then.
Thank you very much. Thank you. Bye-bye.
Thank you, everyone. Thank you, Behzad. Thank you.
Thanks,
Atieh.
Atieh.
Thank you, Atieh. Great job.